Hello, everybody,
Hello.
and welcome to today's webinar. So today we have an interesting topic, and today we will be doing it a little bit differently. Can already see there's two of us here in the screen. Here is my colleague Gašper.
Yeah, I'm
We'll go more details a little bit later. So I see that we still have a lot of people joining up now. So we will, as usual, we will wait for an additional minute until 1 minute past 2. And then we will go ahead and start the presentation for real. Okay, I see that most people have joined up by now. So now we can go and start the presentation for real. The topic today is LiDAR or photogrammetry, making real choice for your project. So we'll be comparing the new LiDAR drone technology with the new photogrammetry drone.
with L3 sensor, the latest sensor from DJI.
So with you today are me. Most of you guys already know me. I'm Vid Peterman from 3D Survey. But with me today is also my colleague Gašper Karlovšek, who's a land surveyor.
Yeah. Hi, nice to meet you. I'm a land surveyor at the company Geo2.do, but we are closely together with 3D Survey. We use 3D Survey from the beginning, and I also work on the projects related on the photogrammetry and LiDAR. So this is my main profession. I'm also working on some projects to how to use photogrammetry in cadastral processing, and yeah, I'm pretty experienced in this area. So I'm also interested in this topic. We bought this new LiDAR drone and have few projects now, and we already see the minus and pluses. So it's nice. It's a nice.
It's interesting.
Yeah.
So yeah, I've known Gašper for a long time actually. So we went to the same school together when we were studying geodesy. Gašper was actually 1 year behind me. But even when we were students, we would sometimes work student jobs or same student jobs together, right?
Yeah.
And now he works at a next door surveying company. So we often have coffee together.
Talk about projects.
Yeah.
Yeah.
And as
Discuss about software and everything.
Yeah. As he said, their company now invested into Matrice 400 drone with L3 LiDAR.
Yeah.
And we thought maybe this would be a great opportunity for us to make some sort of a test.
Okay.
So today's agenda. So as usual, we will start with a quick poll. Just to get to know you a little bit better. Then we will talk a little bit about hardware use. And then we will do the comparison to projects. One will be the rural setting and the second one will be urban setting. After we're done with that demonstration, we'll also prepare results of some sort of analysis and our view of benefits and capabilities of both technologies. And in the end, as usual, there will be time for general discussion. And lastly, but not least, I also need to mention this whole webinar is being recorded. Everyone who either registered for the webinar or just saw a few minutes, everyone gets the full recording in the email. Usually it's about one day, sometime in Friday, on Friday.
Yeah. Nice.
Okay.
So let's take a poll.
Now let's start our poll. So we will start with the first question. So the first question is, what kind of technology do you use in your work already? And we can already see that you are nicely voting.
Yeah. Mm-hmm.
And I think the results will be interesting for all of us.
Okay, so drone LiDAR and SLAM are the
Don't,
same.
don't,
Yeah,
don't give. Let's wait for people to finish something. Don't tell them yet what the results are.
okay. Yeah, but
So-
interesting.
I think, yeah. I think most of you have voted so far. I will close the poll now, and we'll get to see the results. Some people are still adding quotes. Okay, 5, 4, 3, 2, 1, and closing the poll now. And here we can see the results now. Okay, so like we can see, the winner today with 91% is photogrammetry.
That's something to expect.
Yeah, it is a photogrammetric webinar.
Yeah.
And 82% of you are using GPS and total station. I was expecting this to be slightly higher, maybe as much as photogrammetry.
It's interesting. Photogrammetry wins this poll. Okay.
Yeah. And then the third place comes to terrestrial LiDAR with 35%. So 1E3 already.
This is for more accurate measurements, I think.
Yes.
It's probably the best.
23% of you also already use drone LiDAR. So very interesting. So maybe you will be able also to give us some valuable feedback during this webinar.
Yeah.
So we have also questions and answers session. If you have a question, feel free to send it or give some useful insights. And finally, 21% of you also use SLAM. So SLAM is up and coming technology.
Yeah.
I think it's interesting.
It's nice. We also have SLAM, and we use it a lot when it comes with the inner spaces. You quickly get the dimensional, all the places and the windows for architectural and the beam modeling, and it's useful.
Okay. Now, the second question. I will go ahead and I will launch it. What kind of projects do you often do? So, do you do survey maps, or do you mostly work on cadastral and land registry surveys? Do you do volume calculations, BIM modeling, or inspections?
Yeah, what would you expect to be the most?
Survey, I would say survey maps.
Yeah,
volume calculations also, but they're less common.
But in photogrammetry, the volume calculation are maybe the simplest thing to do. Yeah, with photogrammetry.
Yeah, and there is a big added value.
Yeah, big added value, definitely. Yeah. But yeah, also survey maps now without photogrammetry, you put the drone and get the survey map maybe in the background and then draw the 2D map, 3D map. It's nice. Yeah.
Okay, I see that most of you have voted by now. So in 5, 4, 3, 2, 1, and now we will close this poll. Right. Okay, interesting results. So we can see that 86% of you, the clear winner is survey maps.
Yeah.
86% of you do that, and 50% for cadastral measurements. And then we have at 65% volume calculations, 30% inspection, 30%.
Yeah.
And finally, BIM, build an information modeling.
Yeah, but I think this BIM and LiDAR photogrammetry, everything puts together, it's a nice input for modeling. So yeah. Okay, let's go to the next.
Okay, and now the final question. Are you considering investing into drone?
LiDAR drone.
Yeah.
We saw that some of you have this already, but
yeah, I think we forgot to add the option we already have.
Yeah, but I think this webinar would quickly tell you, based on the work you do, if you need a LiDAR drone or not, because in many cases it's I think overkill, but we will see, and you will see the comparison, and we think everything, how to transport it, and everything, how to use it, and you will see the difference. Photogrammetry, it's much
Yeah.
easier, to operate
Okay.
with sometimes.
I see that most of you have voted again. Let's wait 5 seconds. 5, 4, 3, 2, 1. And we will close the poll now and share the results. So 63% of you voted yes. You are thinking about purchasing a LiDAR-based drone, and 37% said no. So 2/3 yes, 1/3 no. I think all of us would be interested to see our comparison of the two technologies.
Yeah. Definitely, we will tell them something.
Okay, let's hide that poll and go back to our presentation. So first, let's talk about the hardware used. So we used the latest Matrice 400 drone and also the latest surveying drone Matrice 4E.
You know, you can see the biggest difference is its size. You know, it's bigger and it weighs much more, the LiDAR drone, and also the payload, the LiDAR sensor, it's big and it's heavy. So
Yeah.
we took 2 videos. Let's just show those 2 videos. You will see how the LiDAR drone puts together, and you can see this case. It's big. You don't want to go with this with remote places.
So
you
yeah,
know?
here to put it. So we decided to put it in the backseat, right?
Yeah.
Because the trunk was full.
The trunk was too small for this, and yeah. So and it weighs, I don't know, 20 kilos maybe, all the things with the batteries and all the stuff. Yeah. So it's you won't carry it.
But you can.
Yeah. And there's also
It comes in 2 boxes.
yeah, special bag for the LiDAR sensor, and you know, you have to unmount it and mount it, and this procedure is not like like plug and play.
But I think you get used to it.
Yeah, you will get, but it's, you know, you have to be careful. I don't know. I'm used to it, you know, with the drones for who have a camera built in. You didn't have to do nothing, and this is like, oh, I hate this, you know. But
Okay.
yeah,
You put the sensor on, then you attach the landing gear.
the landing gear, you have to be careful to
Put the left on the left side.
yeah, because it can flips over the nose if you change them. Here is what I will check once again if it's okay.
You place it, and then you extend the arms.
Yeah. Okay, yeah, this we can go quickly through this, but we really wanted to show you that it is a long process. It's not a long process, but it is a process. Well, when you compare it with a photogrammetry drone,
And then you attach the battery.
Yeah.
And when you insert it, it locks into place with this handle.
Yeah.
What is like about this drone? Up here, there is a special LiDAR sensor for obstacle detector. Maybe like talk about that later. And then we get to mission planning.
Okay, the mission. Yeah, it's probably the same as in photogrammetry. So from here on, I think DJI has a nice setup for planning missions, and if you have those type of drones, this is pretty
So
simple.
it's the same application. You draw the area you want to fly, and then you set some flight parameters.
That's it, and that's how it goes.
And then you start. Here, it's a little bit louder than the Phantom, but it's not too loud.
Yeah, it's big. It's
bigger, but
yeah.
Oh, and now for comparison, there's also me assembling the small drone.
Yeah,
but mostly I think all of you know exactly how this works.
Yeah, you take the cover off and just unfold the legs, and that's it, and it's ready. This is much more simple. So if you got simple terrain, simple things, quickly want to do some terrain job, you get really good results. You will see the results, and then you will see if it's worth to go with LiDAR drone every time. I don't think it's worth to go every time, definitely.
Okay, and then for the comparison, we took some specifications from the official website. So obviously, the first important thing is the Matrice 400. It's about 10 times bigger in terms of weights, right?
Yeah.
So that also means certain limitations for flying the drone.
Yes, of course. You have to, every time you get permissions, and no matter where you are, or the if you're not on the closed area where you can get some other people also involved, you must get special missions, special permissions, and it's more work
More
before
paperwork.
paperwork before you even start to manage.
Yeah. But you have all the papers. You can fly legally anywhere.
Yeah. Oh, yeah. I'm a licensed pilot, so I can fly anywhere. Yeah.
Then main difference is obviously the L3 is LiDAR drone. It's equipped with LiDAR. It penetrates vegetation. Photogrammetry, you have photogrammetry camera.
Yeah.
With LiDAR, you also have 100 megapixel camera.
Yeah.
But for our first flight that we did together, when we were planning mission, the pilot app told us we recommend you enable 7K resolution, right?
Because we fly in just a little above 100 meters.
Yeah.
And in that case,
we didn't know what that means, but later we figured out that means that instead of 100 megapixel images, we got 24 megapixel images. Image resolution was 6,000 something by 4,000. Apparently, they call that 7K now. I think it was very good. These images were good. We also tried processing them in picture.
You can see everything.
Check everything.
Yeah. But I think the main okay, you want to say something about you can see the vegetation penetration. The LiDAR sensor is an active sensor, and it can go through the
through
forests and everything. You can get multiple returns, and with this thing you can get better classification, and you can also get the point of the
same point density,
point density, and the points from the floor where also the vegetation is. Mm-hmm. Yeah, and that's important. Yeah, that's where it's better. That's why we bought it, because that's why we need it.
Mm-hmm. Yeah. Okay, in terms of accuracy, the website says 3 centimeters. We did our test. We will check also that later, but we can confirm that you can get at least that.
Yeah.
Okay, we set up multiple returns, big added benefit. Mm-hmm. Then the battery on the Matrice 400, I think it weighs 6 kilos or something like that.
Yeah,
right?
Something like that. Yeah.
So the flight time, flying time is almost 1 hour.
Yeah, but I will say that we took a few projects now, and I don't think this time it's real, because maybe it's because of the payload of a LiDAR sensor. But I don't think it gets this minutes. Yeah, as written. So we also calculated the area that can measure with one battery, and you can also see that the area you can measure with one battery, it's much bigger with the Matrice 400.
So we did a test. So just to estimate what kind of area you can map with 40 and what kind with 400. So we took the stated flying time and we decreased it by 25%. So here it says 40 flies for 49 minutes. We said, okay, we would 37 is maximum what we dare to fly. And for this one, it said 45 minutes is maximum.
Yeah.
We defined an area. We defined an area so that the flying time would be 37 minutes. And here we got to about 1.25 square kilometers.
Yeah. With the both settings, we want to get 2 centimeters of ground.
So with the 400 drone, it used higher elevation, higher collection speed, and this way we got to 10 square kilometers.
Yeah.
So that's 3 by 3 kilometers.
I would take that carefully. I
Yeah.
think it's at least
That
for-
also means
yeah.
that you would have to fly the drone 3 kilometers away from you, basically.
Yeah. It's one test we lose signal, and when it loses signal, it goes to home point. So
Yeah, that's the
so it won't be on the fly route, and he stops recording. So you have to repeat it, and yeah.
Okay. Finally, about the price, these two are two completely different classes. So Ori, I think it costs about 3,800 plus tax, and for this one, I think it's 25,000 plus tax. So give or take, I'm not sure.
I think it's much more with the LiDAR sensor, and but
I think okay. I think it was with LiDAR sensor. So something like this. This one is a bit 6 times cheaper.
Yeah.
Okay. Now let's go to our first project. We will have a look at how LiDAR works on a rural project. Let's go here and go to 3D survey. So here we have two projects actually. Here is number one. And in this one, so here we have LiDAR project. This is just LiDAR project, right?
Yeah.
So here is the area we decided to fly. And here we only have LiDAR point cloud. And in the second window here we have LiDAR point cloud and photogrammetry point cloud and mesh and everything. Okay, I'll clear that so that the color becomes neutral again. And we also have some control measurements. So why did we select this area here?
Well, this area was very interesting because it had everything. It had buildings, and it had a little stream, and it had vegetation, and it had also power lines, and so it combines everything what you can get on some rural field, and we also make a real measurements here because on the southern area there they wanted to build, and they had to measure this stream because of the possibilities of floods, and they want on this area they will make a building.
So your colleague, one of your colleagues, she measured here. She created a whole survey map using traditional measurements.
That's right.
And she also recorded these vertical cross sections.
Yes.
Or recorded with GPS, right?
With GPS on the vertical method. Yeah.
Okay. So, and why we also selected this one? So very often we would get a question for photogrammetry. Okay, how can you make the river embankment estimations with photogrammetry? And the problem here, very often, that here we will have a lot of vegetation. Here it's best shown on LiDAR.
Yeah, you can see how it is. Yeah.
And if you have that, it might be difficult to assess the actual embankment from this data because photogrammetry produces. Yeah, and we wanted to show that data set where we can
Yeah. And this is one case when you will have to figure out that the LiDAR sensor, if you want to get the correct measurements in this stream, the where it's the vegetation is bigger, not the part which goes under and it's all flint. I will go with the LiDAR drone here because we had the winter and there's not leaves on the trees, and because of this we get also good results with photogrammetry, which is nice to see. And sometimes maybe if you had not so much vegetation, or maybe this kind of field like here, you can also try with the photogrammetry, and it seems
okay. Yeah, if we check, if we now focus on one, which profile we did select. We actually have we also have some photos of these cross sections. Let's go here.
Okay. Yeah, it's
right. So this is how this stream actually looks in
reality. Yeah. So basically, if you see, the changes between the real measurements and the point clouds, or photogrammetry or LiDAR, there are difference, 5 centimeters up, down, somewhere up or somewhere down. But you can see, there's a rock, there's some other things you can.
Yeah.
On the end, it doesn't even matter, because it's the same for the plan at the end.
We can maybe focus on this view here. So this is how the stream looks, and this is how the stream looks in LiDAR data. So we go here to this. Here we will disable this point cloud, and just the LiDAR and make it a bit thicker. So this is the LiDAR. Here you can see we did get some bush.
Yeah.
And here we also have some control measurements. So in this case, one thing to note, in this kind of bushy area, even the LiDAR, it might not penetrate through all the, it still might not get the lowest point.
Yeah.
Here, these are the points measured with GPS.
GPS, yeah.
So when when you measure GPS, so how do you measure this kind of point?
Yeah, you go here and you just record it for, I don't know, 10 epochs, and that's it.
Yeah, and
on Ertica method, you can expect that there's a variety, of 3-4 centimeters in height.
So here the points measured with GPS are approximately 15 centimeters lower than the point cloud. I think some of that also, you take your stick
and put it in the mud, and it first go 5 centimeters definitely in the mud, and then you get the wrong altitude or the right.
There's also a lot of things here on the edge, and if we will look at the point cloud, we will see if we make a cross section. There is some generalization going on.
Yeah, of course. Yeah, you can see on the LiDAR. The LiDAR sensor, there's some applications when calculating the LiDAR model. So it, I don't know,
if we now try to check certain cross section here, and
what is this in the background?
That's just something, so I think it comes from the stream, because it reflects.
It reflects, yeah. So, okay. There's also noise with the LiDAR.
So here you see the GPS measured,
yeah.
Elevation. I'm going to see disable the mesh here. We don't want mesh. GPS measurement will be, for example, 2 meters and 19, and here the point clouds they're about 10 centimeters off.
So yeah. It's generally
I think that's the problem, because the vegetation here is very thick.
Yeah, it's the first thing is this, and the second thing is with the stick you put it in the mud, and you're quickly 5 centimeters in the mud with the stick, when measuring. So, but
all in all, here would have to take innovation like here. All in all, we would say you can LiDAR is helpful here, right?
Yes, definitely it's helpful.
If you go to point cloud, so maybe even if you better just some of the ground points. Like that, yeah. It's always scary when you do.
Okay, now.
Yeah, now we are doing the screen recording, and it adds extra strain to the GPU, and we are on laptop. And here we now have just the points from LiDAR classified as ground points. Yeah. So this classification is done already in DJI Terra, correct?
Yes, correct.
So we do see that maybe potentially it would make sense to do one more step of classification with, of course, 3D survey.
Yeah.
Because 3D survey would remote distance.
Of course, it will. Yeah, it's because of the area, because there's lots of this Brezina. I don't know how this
The slopes.
the slopes. Yes, and the slopes are maybe so slope because and they're
Yeah.
changed for the build.
Also,
Yeah.
they use a little bit different classification. In Terra, you set maximum size of a building. It's at 30 meters, and it's a parameter.
Yeah.
Classification. I did see similar things on the other ones. All right, so let's go here. Indeed, this part there was more vegetation, but we would say LiDAR ground here could be usable, but
Yeah.
just you need to take into account that the GPS you still measure a bit lower points. Yeah. If we enable here also photogrammetry like that, it's similar story. You also get less sometimes where you might want to have points here, yeah, but there are more holes in the point cloud. So yeah.
Yeah,
But in the end, what technology would you use to create?
Yeah,
those sections?
now when I know that I get similar results with photogrammetry, I would go with photogrammetry. But and the first, because I know there's a stream and there's a vegetation, I would prefer to use LiDAR. But there's the case where also photogrammetry will turn out well. Yeah, yeah.
But maybe but traditional measurements are also.
Yeah, of course. You always have to do some control measuring, to be sure. But if you look here at the forest, at the part where the forest is, this is where the strength of LiDAR is.
Let's disable the photogrammetry and enable LiDAR.
Yeah, you get the ground points through the trees, and
so this is the terrain that was extracted here.
Yeah.
So it looks pretty good. Right?
Yeah, it looks perfect. So in this case, there's nothing else. You go with LiDAR. Yeah. If you need the terrain. Yeah.
Okay, but even here you have options. So a lot of countries now they also have national
LiDAR. Yeah, you don't need in the forest. You don't need the terrain accuracy below 5 centimeters because there's leaves, there's everything. Even with the LiDAR, I don't expect here if I had some classic measurements here to be accurate like under 4 centimeters, but it's enough to get the terrain, to get the shape of the terrain, and maybe contour lines and for the plan, and that's it.
Okay. And finally, okay, if I bring back the photogrammetry, yeah, we have under the forest. It doesn't work. It only works where we can see with the vegetation. Right. And finally, we also had some power lines.
This is where the benefits of LiDAR also.
Yeah, look at that.
Yeah.
So here the power lines, you can clearly see each power line.
How is it going in everything? Yeah.
With this photogrammetry, you get some, but not. There are parts missing.
Yeah. If you just want to measure the power line where it is and that's it, the photogrammetry is enough. If you want to expect them,
but if the power lines go through the forest, then you need to map that corridor, the power line corridor, or if you want to calculate how far the vegetation is from the power lines,
then the LiDAR is the only thing to go. Yeah, definitely.
The question is only how many kind of projects you can get.
Yeah. There's in Slovenia, I think those companies,
company.
Yeah, they have their own drones and they're working on it alone. So
okay,
this is not for a survey company, maybe.
And finally, so what we like about this area is we had this traditional measurement. You can also check the accuracy of data here.
Yeah.
So now, for example, let's do like that. We make the LiDAR point cloud more reddish color, like that. And we make photogrammetry point cloud bluish color. Which is this one. Okay. And now we can see the comparison of the two point clouds. So here very nicely, total station laser was used to measure this point with the total station.
Yeah.
And here we also have the cable with photogrammetry and with LiDAR.
Yeah.
So here with photogrammetry, LiDAR you see it almost produced two lines.
Two lines. Yeah. Yeah.
Maybe we had some wind.
Maybe also, yeah, with the wind when it goes to one direction and another, yeah, it's possible, yeah. But yeah, this is so close, this is a few centimeters,
We can actually measure it.
measured it because I think this is so close that it doesn't matter.
How do we turn it like that? See again. That's like the measurement green. But we can got this layer. And we're interested just in the distance. On here. In here. Okay, not good. Not my best measurement. Yeah, you see, I accidentally measured the length.
Yeah, it's hard to measure here. You have to use bounding box on this.
Yeah, because I want to spend too much time on it.
If you wanna do it, okay, yeah, that will be better.
It says 20. Well, it is a bit 20 centimeters. No, the lines are long. If the wind movement is quite impossible.
Yeah, I also think, yeah. Okay. It's interesting.
And more interesting also here on the ground, we have lots of control points. We can check a few, how this fits together. First thought, surprisingly, we see that we got very high accuracy with both technologies, both with LiDAR and with drone photogrammetry. So if the photogrammetry point here has some elevation of 51 centimeters, the LiDAR point has 51 centimeters. Here's photogrammetry point with 52 centimeters, and here's control measurement 50 centimeters.
It's the same.
It's all they're all within a centimeter of each other. So this is within parameters.
The all we have to know that the LiDAR and the photogrammetry was without control points.
No, in this case, actually,
you use
for this one I used.
Okay, with this one you calculate
photogrammetry, but for LiDAR, it was straight like
LiDAR is without photogrammetry. It's just a LiDAR and that's it, and it comes together pretty awesome.
Yeah,
and these are
check here
results.
Check here, LiDAR 19, photogrammetry 89.
Yeah.
If we say that both have 2 centimeter accuracy, here it seems that the accuracy might not be better than 2 centimeters. Which is perfect, I would say. So here, this measurement, here we have a bit more deviation, 82 on LiDAR, 80 on photogrammetry, and this one is even lower.
Yeah.
But maybe, this was measured with GPS, and here we have vegetation.
Vegetation, and that's what it comes.
It's something very bad.
Yeah.
Okay. But all in all, we have very similar data here. You can check here on the slope, 32 and 25.
Mm-hmm.
But here it slopes on the
it doesn't change anything, but it's between centimeters. So this is correct, definitely.
So all in all, in rural setting, go back like that, and I would maybe leave this one.
Mm-hmm.
Let's take it in natural color also. Rural settings, LiDAR performs nicely, right?
Yes, definitely. LiDAR it's nicely, but I can say with photogrammetry we get the correct result. We wanted to show in the beginning the the struggle to put together the LiDAR drone, everything that goes, if you're planning a mission with the LiDAR drone, it's much more time consuming and it's bigger and everything, you know. So why would you choose a LiDAR drone when you can choose easier and quicker photogrammetry drone? And also this area, it's a small area. You can this is, I don't know, with how many battery did we use? I think it was like 15% of
like some.
Mavic 4A. So nothing. You can also project how many images did we make with the.
So yeah, with photogrammetry, we might hear 300 images.
Yeah, that's really not a lot of images.
Okay.
Yeah.
Before we finish with this project, I would like to also show you a second thing. So in this project here we have imported LiDAR point cloud. Yeah. But also along the LiDAR, I also imported LiDAR photons. So here you see there are 6,000 by 4,000 pixels. So this was set to this was set to 7K resolution, what they call it in 24 pixels. That's it. And these are the photons. So if we import those photos in and we do bundle adjustment, that means that we'll actually be able now to use the power of 3D survey drawing with image support. If I come in here, so there, this building, this wooden structure was being taken apart while we were mapping. And if I come in here, I go to CAD, with this layer, for example, and start drawing here. We get here the photo position of where we click, and I can then improve my point position. Maybe that should be there. In this direction, measure to here.
Yeah.
And improve that.
So that's the main benefit of 3D survey. I can use Terra for calculate 3D model, but in the end, it's the same quality. But I can say this is the power of 3D survey. You can do and make the exact points you need for your plans. And
it also helps when you are if you were to draw a map based on this, it will show you here where you are clicking.
Yeah.
And when you rotate, this still works nicely. It selects this kind of photos.
Yeah.
Okay, it's a top feature for me. So, thank you. So, if we go now to continue the comparison, now let's go to the second part. And in order to do that, I need to run and open another project. Okay, here. Project open. And one more part. Unfortunately, this will take about a minute to load. And in the meantime, you can also close this one just to have a bit more space and RAM available.
Yes, this
and for the second project, we have selected more urban settings.
Yeah. And this is also one construction project in Ljubljana, Slovenia. We took measurements of this project. We have to make the project for as made
as build documentation.
So how does it compare to the project? And we took also traditional measurements here, and we want to see how it goes with LiDAR and how it goes with photogrammetry. And
so we decided not to take the easiest example, because these new buildings, they have lots of windows, they are quite complex, they have very uniform color. We selected them so that LiDAR would have added value.
Yeah, that's right. That's correct.
Okay, let's see. The project has finished loading. Yes, it has. So here in this example, again, we did a similar thing. We have here in one project together photogrammetric and LiDAR point cloud. So this is LiDAR and this will be photogrammetry. We just need a second, then we enable it. So here we set, the previous project was set, ground spacing resolution was set to 2 centimeters. But for this
Yes.
one, we used a little bit lower, right?
Yes, that's right. We fly here a bit lower. We wanted to get still the same ground point accuracy, the same. So we fly with the LiDAR above 80 meters, something like that, and with the photogrammetry drone, it was like 40 meters,
35, I think.
35, yes. And this equals the 1 centimeter ground point.
And for photogrammetry, here we use the new flying mode, the smart oblique.
Yes.
And also for added accuracy, we also did 2 orbital flights.
Yeah.
So here initially we wanted to use the built-in orbit function. I think they changed it just a little bit. On your flying, we could not start it, so we just put it manually.
Yeah, but if you fly often, the manually, it's better.
Actually, I always use the automatic version now. The manual produces better results.
Better.
You can.
Yes, and you're
more in control.
Yes, and you're more concentrated to see what you want to have in your photos, and you can look and control the drone and take a photos at the same time. For me, I mostly go with my hand, and I think when I go with it, I take the less pictures and I get the best results with that.
Yeah. So here, this is a bit hard data set. You see up here these blocks, but these towers, they have lots of vegetation and
details.
Lots of details.
Yeah.
Mesh came out surprisingly well, right?
Really nice. The mesh is really nice. I'm really surprised. We didn't expect that good. That would be as good. But it's nice.
Yeah. So super nice 3D reconstruction. Even useful for
everything. I checked the plans. I don't know what you thought about this. When you took the measurements and see the true orthophoto and the position of the points, you see that you don't need to take the measurements.
Yeah, and in this case, this is definitely one added value from photogrammetry, right? Because you also get this kind of mesh.
Yes.
You also get a mesh from the LiDAR, but it will be lower.
It's lower quality. Yes, it flies higher because of the sensor, which is this type. But it's nice to have a really detailed. You can see every
small
detail on the ground. Yeah, and you can
talk more about this side here. So, what were you mapping here?
Well, this was a construction site. We have to measure the buildings and we have to measure the surroundings of the buildings, how it's done, the new road here. Everything was done here with this project of these new buildings. So we have to measure everything. This how does it call the
curbs?
Also the curbs and also the with the water lines and the other lines that goes. You can see this
these covers here.
Yes.
And also the blue points, they were all measured with the
traditional survey. Yeah.
So that was done a few days prior to our mapping.
That's right.
And then last Friday we went here and we did the 2 surveys together on the same day
for this webinar and for our control also.
So, what was special about this project here? When I was processing the photogrammetric part, I actually, but here, okay, no, never mind.
The one control port was someone has to change its position between the flights, so we have to eliminate it. But we have one spare, so it's okay. Anyway,
okay. So here now let's check the difference between the LiDAR point clouds and the photogrammetry point cloud. And I will disable the camera views like that. So here we have the LiDAR point cloud.
It's clean and it's Yeah.
I did notice here it produced less
Yeah, on the
than we would expect.
yeah, it's less. I don't know why, because set the wider area to map, and some facades are good and others are not good. I don't know why. Maybe I should change the direction of the flight. But
I don't know either. Maybe because not hard to say.
yeah, it's hard to say. It's hard to say. But it's the other parts are really nice. But and you also get the exact points. So the LiDAR doesn't get bad
Yeah.
here. It's,
So the
it's
LiDAR
great. Yeah.
is mapped up to here, and the facade here is sort of mixing.
Yeah. Because it's higher and it's more directly on the
Maybe
ground.
maybe the angle between the laser beam
Yeah.
and the facade is, it goes at this direction and the intersection is that.
Yeah, maybe. Yeah. Maybe you should do also this from the side LiDAR scanning.
Maybe here too we should have done additional manual flight.
Right. Yeah. Okay. Let's go on.
Okay, that's about the facades, but in terms of accuracy, you can check that. Let's do the same thing we did before. For color. So the LiDAR will again be reddish. For this one, blue color. Like that. And control measurements. What should we make them come out? Something that will stand out.
Yeah, in the green.
Okay, this should be clearly visible.
Yeah.
And let's check with the point cloud. Right. Let's zoom in. So here we have a check elevation. So elevation measured with GPS is 99 centimeters. Photogrammetry here is 97.
The LiDAR, it's a bit.
And the LiDAR is 300.
300. So this is about
3 centimeters difference, and this one is right in the middle.
Yeah, here we set photogrammetry and LiDAR without control points.
Yes, I calculated twice. Here it is actually point out where ground control points were not used. And we were surprised that
this is the both point clouds are without ground control points.
And so here, actually, what we figured out in this area here, we have very constant difference. So LiDAR is constantly 3 centimeters above photogrammetry, and the control measurements are just in between.
Yeah.
So here we have control measurement is 83 centimeters, photogrammetry is 81, and
LiDAR is 85.
So here it's okay.
Yeah, it's 3
centimeters. So the stated accuracy was achievable without any heads up.
I don't think if you go with any of this, you just go to measure.
And here, same thing. LiDAR 1 centimeter above checkpoint, and photogrammetry 2 centimeters. So I think this is, and we actually did some cross sections. We check those. You will see the same thing here. So here on this side, the anchor points, create those points. And here elevation will be approximately 1.4.
Maybe you can show the curves. The curves. You know how it's.
Oh yeah, definitely.
Well, it's not here.
And this one is 164. So here we have 2 centimeter elevation difference.
In 45 meters, I think here you can see them.
One interesting thing.
Both of them,
a lot of surveyors ask us, how does this technology work on curves? Can you extract curve conventional jumping data? We see so the blue one is LiDAR, and also what we see nicely here, LiDAR data. You can see that there is some denoising happening here. Yeah, because you see, it's like the points are moved to some mean surfaces. Because with photogrammetry, we don't apply those filters. It might make sense to add them as well, but here from the point cloud, get some noise. Each point gets some noise.
Yeah.
I see. Yeah, we could apply the filter to the point cloud and put this kind of result.
Yeah. But okay, what I want to show is that we get the curves. You can see where it is, and you can draw it on your plans, and you can draw the what's the difference between down and the upper part of the curve.
The curve here is
12 centimeters, and you can see
12
here
centimeters in photogrammetry. The only problem is it should go straight, then straight down, and straight again.
Okay.
And the same thing for this one, it should go straight to here. About this elevation,
maybe a bit further,
and then to here and up here, and there. That's
okay.
Obviously, this is going to be an issue. Surprisingly, here we saw one thing.
Okay.
This fence here, photogrammetry reconstructs it.
Yeah.
LiDAR only reconstructs the couple of points.
Yeah. So with photogrammetry, you get more detail, definitely.
Yeah, and if you go back, like the color is back normal. It's also, if we check first photogrammetry, for example, super detailed, lots of small detail. Actually, almost worked fine on the glassy areas.
Yeah.
If you check the LiDAR, also super detailed. I would say slightly more. You can see the effect of denoising.
That's it. Yeah, but it's nice effect.
Yeah, it's nice. You can see the constant. So the density, the point density, is more constant.
Yeah, that's the main advantage. The maybe also if you see how many points are in the photogrammetry.
So the LiDAR point cloud has 32 million points.
And the photogrammetry has 45,
85, but you have slightly larger
area. Yeah, but that's why also
in the same area we would have to do this.
Yeah,
and click the other, and it will take maybe 10 or 15 seconds,
and then we can compare one to another.
I have this one disabled.
And then go to undo and make it again. We can compare, But I think the LiDAR data will be a little bit smaller compared to the photogrammetry because of the noise and everything. It's so maybe it's a little less space comes on,
but you use this narrower area. Other. And now, the gravity has 40 million points, and LiDAR here we have 30 million points.
Yeah, much less. It's much less. It's down by 4, almost like 4 times. Yeah. Okay.
Right. So we are running slightly late. Let's go to our analysis.
Yes, okay. Yes. I think we told everything. You can see the difference by yourself. I wanted just to say about this project, I will use the photogrammetry every time if you ask me
for this kind of project.
For this kind of project, because one thing, that's it's an area that can go with people and everything. With this big drone, there's plenty of risk.
You need bigger landing spot,
all documentation and everything. What goes with the LiDAR, it's it's time consuming. At the end of the day, the result I want to have to make some plans and everything, it's the same. Then why go with the bigger and everything if I get the same results or comparable, which I can use on the same way? So,
okay.
Yeah.
So here we have some spreadsheet. First, we figured out when it makes more sense to use drone LiDAR. So we figured out first, for large-scale projects, if you have ability to use LiDAR, it definitely makes sense, right? Because calculation will be faster. You will cover more in single flight. So here, like drone LiDAR, if you have an option, it might be better choice.
Yes.
But if you don't have a LiDAR drone, even with the drone photogrammetry, you can still cover large scale projects. You just have to do more.
We go when we talk about large scale project, it's more than 5 square kilometers, you know.
Something like that.
Yeah. Not like a half a kilometer. This is a small scale.
Then the second, where we have very big advantage of LiDAR is when we need terrain under that vegetation.
Yes.
So you had a similar project, right?
Yeah.
Did it?
We have a landslide we have to observe in the western part of Slovenia, and we take measurement with LiDAR. We get the LiDAR, the whole area is full of trees, so you won't get with photogrammetry anything usable. And we choose to take LiDAR measurements, and it turns out really great. You get the ground points really clearly. You can see the slide, how it goes in for observation. And also what I can say, when we compare it to state LiDAR, we can also find out the movements of the slide, how much it moves.
You can even see how much the trees move.
Yes, everything. So it's nice. And for one slide, we didn't know we was like we had a flight. I think it's 60 meters below terrain, and it was like so much detailed. We can see the diameters of the trees and everything. So it is it's a nice for a vegetations area. Yeah, definitely.
Then we also think that the LiDAR makes a lot of sense for corridor mapping, like power lines and pipelines.
Yes.
Because very often this kind of things will also be in forests, right?
Also forest, or also a big scale. You know, you have a power line of few kilometers. You won't go with the photogrammetry.
Yeah, photogrammetry will work well in open areas, but if it's a long area,
yeah, it's better to go with LiDAR, definitely.
Okay, and you get very good. The vegetation in very high detail, so you can even calculate how far the vegetation from the power lines are already cut.
Yeah, that's what we talk about. Yeah.
And finally, for city scale mapping, so sometimes I get questions from potential customers who say we would like to map the whole town, large town. We'd like to extract all the buildings.
Yeah,
I think for this kind of project, it would make sense to go with the big one.
Yes, definitely with the big one. If it's big enough, you know, if for the city size, like like Ljubljana, it's also the big one is too small. You know, it's for the small cities. You know, it's still the 10 kilometers range with one battery. You know,
and finally here we then have projects where we think using typical drone survey with photogrammetry that it makes more sense. So here we have for standard surveying projects.
Yeah.
So this will be like as-built documentation, survey map,
volume calculation, construction sites. Okay, yeah. And also, if you want cadastral procedures, you want to take
you need orthophoto
of one building, you can easily
you get that better.
Yes. You can measure all the things you need about the elevations and everything you need.
So here we wrote for LiDAR, it's possible, but often unnecessary.
Yes, it's overkill, definitely. As it's stated in the
And here we think it makes sense to do that with photogrammetry. Then construction sites, we thought it only might make sense to do them with LiDAR if they're covered with vegetation.
Yeah, but construction site never it's covered with vegetation, so it's ideal for photogrammetry. As we've seen, it's there's no need to use a LiDAR there.
Yeah, for volume calculations and stockpiles, definitely LiDAR would work well, but photogrammetry is more cost effective.
Yes, of course, definitely.
And for visual inspections, mapping with imagery, we saw that we also get images from LiDAR, but in the end,
in the end, for the same result, you always go with the smaller drone. That's what we want to tell in also today. That yes, LiDAR, it's it's expensive, it's bigger, and it gets really good results. But you don't need always that kind of results with the basic workflow you have. So the photogrammetry, it's easy, it's smart drone. You just put it on the ground and flies, and it goes everything. It's in 15 minutes and it's done. So this is the main advantage.
With a small drone, you will be able to go closer, record the images from closer.
Closer.
The big one, you need to be more careful.
Of course. And Matrice, it's super okay for this.
And final slide, we prepared some key differences in practical terms. So we think drone LiDAR mapping best suited for projects where terrain geometry is priority, especially in challenging or forested environments. And typical applications, we said large scale mapping, whole city scale surveys, anything with forest, and for corridor mapping will make sense. The main advantages are it penetrates vegetation. You can cover large areas if you fly high. It's efficient for large scale projects. We get consistent point density, which is also very nice.
Yeah.
And processing is also faster because you don't have to calculate that.
Yes. If you
And on the other hand, drone photogrammetry, best suited for standard surveying applications where higher images and visual interpretation can also add added value, like when doing survey maps, it helps you have a clear photo, you see what you are drawing.
Yeah.
So typical applications here, we selected construction site mapping, topographic surveys, and any kind of open areas, stockpiles and open volume measurements. Then you go to photo, and for inspection of infrastructure when the image is already enough.
And the
main advantages we said photogrammetry, detailed imagery because it can be often recorded from closer.
Yes.
Surface detail will be excellent mesh quality. Lower equipment costs, less than a sixth of 1 divided by 6. And by now, photogrammetry has become widely used. Everyone is using it.
Definitely. But the LiDAR is coming, I think.
Of course.
But I will probably in the future we will see the smaller LiDAR sensors and everything. Definitely.
But now between the L2, L1, L2, L3 is a lot bigger.
Yeah, L3 is it's a big box. It's much bigger than L2.
It used to be smaller, but it's also more precise.
Yeah, that's it. And one more thing that the advantage for me with the photogrammetry is the simplicity of work, the terrain work, because it's in few minutes and everything is done. Yeah.
Okay. Finally, we came to our last slide, and now it's time for our questions and answers session. Let's have a look. We have a few questions, not many.
Okay.
So for those of you who are in a hurry, if you need to leave now is a good time. We will now go through all of these questions that we received one by one and see if we can answer them. So for now, we have 4 questions. So the first one is from Richard. How many measurement returns per point are you getting with your LiDAR sensors?
I think it's 6 in the specification. I think it's 6. I don't know exactly. But DJI has it in specification. You can find this there, definitely.
Then we have a question from Gregor Zorsch. He's asking, hello, we have a terrestrial LiDAR scan of the interior and drone photos of the exterior. Can you create a combined 3D mesh? Okay. Mesh, currently, mesh from LiDAR scanning 3D survey. Our algorithm is at the moment not optimized for this kind of data. So the mesh that we calculate directly from images. So for each image, a depth map is calculated, and those depth maps are then merged into a single mesh. So for LiDAR, I think the plan is still with our full update to also include the mesh calculation from LiDAR scans. So that is from handheld SLAM scanners and also from terrestrial ones. With this new approach, I think then that might make sense. But for now, I would recommend you to merge point clouds or do the mesh from the for the outside use mesh and for the inside point cloud.
Point cloud. Yeah. It's we use also the oh, I don't know, these American LiDAR sensors, which go. The result is the mesh Matterport. Yeah. So,
Oh, okay.
yeah, but you can't combine it. You can buy a mesh from them and then put it in 3D survey and also mesh from the surroundings and put all them together. We also do this in one project, and it goes okay. But you have to have a calculated mesh with the software which LiDAR provides. Yeah.
Okay. So Lena says, so maybe we get someday LiDAR in the size of Matrice 4E. Yes, maybe with Livox LiDAR that would be probably possible already today, but then the quality is, for now, it's still a little bit lower, but let's see what future brings.
Let's see what it brings. Yeah. It should be interesting. Yeah.
Joseph says, thank you for the webinar. Thank you, Joseph. Thank you for joining.
Just a second. Would you say that it makes sense to share a LiDAR drone and that it doesn't make sense for every survey construction company?
Would you say that it makes sense to share LiDAR drones and that it doesn't make sense for every surveying or construction company to buy one? Actually, our drone DJI drone distributor, he had the same idea. He said, why should each company buy this drone outright?
Yeah.
Why don't you just rent it if you need it a few times? You need to do a lot of projects before you do this investment. I think it might make sense.
It might make sense, but if someone asked me to lend our drone, I would be a bit skeptical. You know, it's a lot of money, and if anything goes wrong, it can go wrong quickly. You know.
Then we have DJI Terra is capable to export a 3D mesh from LiDAR point cloud PLY OBJ. I could import this mesh into 3D survey, but it seems that the geotransformation does not work. For imported point cloud, it worked, but for mesh, any tips? My guess is that when you export OBJ from the DJI Terra, what DJI Terra does, it exports the OBJ with local coordinates.
Yeah.
And it will create a separate file where it will state the insertion point. So what you need to do in this case is you start a new project, you bring DJI Terra mesh in, then you need to find that file. I think the file is called meta.xml, as in metadata or something like that. There will be 3 coordinates, easting, northing, and elevation. Then you come to 3D survey, go to that mesh, right click on it, and select transform. And then for the transformation, you input those values that you get from the file. So if you need the additional information, send me an email at support@3dsurvey.si, and I will support you with getting that one georeferenced correctly. Here it says results would be much better if you had control points. I'm not sure. They're so good, you know.
Yeah, we are in RTK accuracy. You know, in RTK accuracy, if you measure 2 points with the GPS RTK and then measure distance with the total station between them, you get centimeter 2. So I don't think much better. I don't think
even for the GPS measurements, if you measure GPS, you know, if you do 2 times, maybe there will be 1 centimeter or 2 difference between them.
Yeah. Also,
so you don't even know if how accurately the ground control points are measured. And also, it's centimeter
accuracy. But if we measure ground control points, you know, with the total station, with the millimeter accuracy, definitely the whole point cloud will be better
And if
accuracy.
you do it like that, everything should have higher accuracy.
Okay, exactly.
How much faster is LiDAR from photogrammetry processing on a project with about 1,000 photos? Yeah, I would say that LiDAR processing for this kind of project, it takes on our computer with 2 GPUs. I think it took about 2 hours.
Yeah, but it's what it is a half time or maybe
Maybe
one
it's 4
third,
times as fast.
4 times. Okay. Yeah, maybe. Yeah.
Then a question from Tom. Can I use a GNSS receiver and enter GCPs to resolve the difference between LiDAR and photogrammetry point clouds?
Of course. It's just to register them together to the same points. So you can use this. Yes. You measure the ground control points with the GNSS receiver and took them like in survey.
Yeah, and you can, so in this case, in our case, where the photogrammetry was approximately 2 centimeters below the
Yes.
control measurements, we would raise the photogrammetry by 2 centimeters, and LiDAR, we would move it down by 1 centimeter, and then they should fit
Much
perfectly. And we can actually try that. I'll just press clear here. Select that one. So we set the, so let's just see one more time so that I don't move it in the opposite directions. That one up also. And like it a bit quicker. So photogrammetry is now
no, it's
so we need to move photogrammetry down.
Yeah.
Here in my export. So here minus, I think it's we had 2 centimeters approximately.
Yeah.
Make sure this one is disabled. Confirm. And this one we said you raise it by 1 centimeter. But you maybe don't need GPS
to do this. You can just register them together. Right?
Yeah, you can just do a couple of cross sections the same way we did. You figure out the elevation difference, and then it should be much less. So here I need to now create a new cross section. Let's see how it will be. Maybe here. Probably I moved it in the opposite.
I think you moved it in the opposite because the photogrammetry was lower than the LiDAR. Yes.
No.
Okay. But you know what we wanted to do.
Can 3D survey combine LiDAR photogrammetry data for more detailed clouds?
Yeah.
Yes, you can. If you come here back to 3D survey, if you want to merge this two into single point cloud, you just click this button, merge. And new point cloud will be created. It will be called point cloud 2006 and the time plus point cloud plus cloud merge. Both will become one, and this two will become disabled. So yeah, very easy. Okay, a question from Alesh. Do you subtract the height of the grass cover from the photogrammetry result? This is a question for you, Gašper.
Subtract the height of the grass cover from the.
So imagine that you are mapping outside.
Yeah,
the grass, the terrain there is slightly higher.
Yes, but I would do that. I will when I go to point snapping or something like that. I would always check for the areas where is not much vegetation or grass or trees or anything. So that's why I want to eliminate those things as more as I can do. And sometimes when I can't do it, it's a problem. I can say it's a problem because if you in I don't know in the May when the grass is high and you do a photogrammetry test, you won't get the floor. And
that's how they do that. Do you take some control measurements and check what you get with the GPS on top of the station?
I always make ground control points and I put them on the grass just for purpose to see the ground where it is, and then I can see on the
how much you need to lower
on that side. But you want this is just
Yeah, it's might be a bit of rule of thumb, right?
yeah. It's not so good. So I don't know if I knew I would measure some grassy fields, that they will do the measure that I don't know, they will do some project there. And I was always say, okay, is it this field clean? Is the grass cotton? Yes, it is. Okay. And if not, I will ask them to cut the grass before I do the photogrammetry.
Okay, and now the last question. Is the L3 better than L2? Did you test the new scan methods? Yeah, the L2 we didn't test, but
we
had
had
one with the L1, right?
No, I was. We took the L2 measurements in one open. Yes, open.
Open pit mine, maybe.
Yeah, pit mine. Yes, that's it. But I didn't have the time to see the difference from L3 and L2. But I think L3 goes with much more detailed. Definitely, it can fly higher for the same accuracy. So combining those two things together, it can get wider areas.
It's also bigger scanner, so I do think that they improved it and that the newer one had started that probably had better accuracy.
Better, yeah. But I didn't test it, so this
Yeah.
is just my guessing. And yeah.
Okay, and that was the last question. Thank you all for joining our webinar. It was a pleasure hosting it. And thank you to those who stick to the end. And until we see each other next time.
Thank you. Thank you for listening. Bye.
Bye.
Bye.